Lesson 10-2, probability and counting. So book starts off with Venn diagrams. I think is a good visual of different events. And the intersection of two events is one event happens and the other event happens. I'm gonna write this out on paper so it looks clearer for the video. Okay. So intersection, you can think of as the word and, right? So both events have to happen, and you can write that as A, and it looks like an upside down view. So that's this intersection symbol, B. Okay. We'll look at some examples pretty soon. Okay. The other main example, or the other idea is called union. Okay. So union, you can think of this as the word or. One event could happen or the other event could happen, which actually expands the likelihood, the probabilities. This would be like A union B. Right? So here's your union sign. Looks like copy U. Okay. And the Venn diagram that would represent like all the possibilities here. So again, the intersection is just this part where they overlap, and the union could be like everything that's possible in either circle. Okay, count both. And so let's look at a more concrete example of that. Okay, so find intersections we got here. Okay, so example 22 are intersections and example 3 is a union. Okay. So it says a fair die is rolled once. Let A be the event of an odd number. Okay, so example 1. Okay. So okay, and then B be the event of a number greater than 3. Okay, so A, well, I know a die has 6 sides, so an odd number could be a 1 or a 3 or a 5. They're your odd numbers. Event B says rolling greater than 3, which could be a 4, a 5, or a 6. 4, 5, or a 6, right? Because if you roll a 4, 5, or 6, you roll greater than 3. Okay, so what is um, A intersection B? What is that? Right. And here I can give you guys a visual. Yeah, I like that Venn diagram visual, right? We got event A, event B, right? All right, so event A could be a 1, 3, or 5, could fit anywhere in the circle, right? But look at the number 5. The number 5 actually could also correspond to event B. Then we put 1 and 3 strictly in A, but 5 could be either one. Okay? And then for event B, you could have a 4 or 6, but again, event 5 is shared with event A. So, or rolling a 5. So the answer is just 5, right? Uh, Only if you roll a 5 there. You would draw the die at. Right? If you see 1, 2, 3, 4, 5, right? That's the only number that's both odd and also is greater than 3. Right? That's the only possibility. Okay. Because if they said something like, what is a union be? Right? Because remember, this right here is intersection. Intersection, right? Which is just that right there. Okay. This right here, if they say union, right? Which is like or, as opposed to intersection, which is like and. Okay. Uh, then I would say, well, it could be any of these numbers. So pretty much anything except for 2. So it could be 1 or 3 or 4 or 5 or 6. Right? Like if you roll pretty much anything other than a 2, then either you've rolled an odd number or you've rolled a number greater than 3. Yeah, there's that. So there's your intersection and there's your union. There you go. Example 2, probability of intersection. Oh, okay, so we're continuing with this idea of intersection, but now we're gonna put some probability on it. Like for example, the probability of rolling the number 5 to be 1 out of 6, or like 16.7%, something like that. That a card selected from a standard deck of cards. Well, you guys know there are 52 cards in a standard deck of cards. That could be helpful. What's the probability that the card is a queen and red? Okay. So example 2. Okay. Right. So let's call event A that we draw a queen. Okay. Let's call event B that the card is red. Okay. Now, here, look at their Venn diagram here. Okay. There are only 4 queens, so there are 4 cards you can draw out of 52. Okay. So here I'll say 4 out of 52 cards. Okay. But red cards, like half the cards are red. That's 26 out of 52. Okay. And you can see it right here in this Venn diagram. right? That there's only two cards that are both red and queen. Okay? So if I write, what's the probability of A intersection B? Right? So this intersection, remember it means and, okay, means that both conditions have to be true. Okay? And you can see right here, there's only two cards. Okay? But okay, now the fact that we're doing probability, that was not different than the last one. Okay? I'm going to make a fraction, 2 out of 52 cards. Okay? Because if you just draw one card, you could draw any of these 52 cards. Okay? But for this particular situation, that you want to be both red and queen, there's only two ways for that to happen. So it's a 1 out of 26 chance that reduces to as a fraction. And if you want to turn this into a decimal or percentage, 2 out of 52 or 1 over 26, same thing, 0.038, I'll say approximately, or 3.8% of the time. So 3.8% of the time, if you just draw a single card, it'll be a red queen. Okay? Now, you know what they did not ask here, but I'll do an extra one with you guys, is what if they change the changes to or? So what if they said probability of A or B? Okay, so now notice I changed this to a union sign, union, which you can interpret as or. Well, now we have a lot more possibilities to play with because it doesn't have to be queen and it doesn't have to be red. Right? It's just like this whole space right here. Right? Okay, and then we got all these cards to the side, which are neither red nor queen. Right? So how many reds plus queens are there? Well, I know that there's 26 red cards. Okay, two of those are already queens, but there's an extra two cards that are not red, right, that are also there. So there's like 28 cards that I could pull out of 52. Okay, so the probability that it's either a queen or a red card would be more like this, which is a much greater probability. Okay, all right, so we got some intersection going on, we got some union going on. Okay, example 3. All right, now this actually is properly a union example. A fair die is rolled once. That's a fair die. Give you guys a little picture here. It has 6 sides, or numbers 1 through 6. Let event A be rolling a number less than 5. Less than 5. So we got some discrete possibilities. It could be a 1, a 2, a 3, a 4. I think that's it. Those are less than 5. Let event B being rolling a multiple of 2, which is also called an even number. So event B could be an even number. That sounds like a 2, a 4, or a 6. Okay. What's the probability of, find A union B? A union B. Okay. And if you glance ahead a little bit to how they construct this answer, yeah, they got curly brackets, and we're going to list all the discrete answers. Okay. I'll do a little extra with you guys. Let's do a Venn diagram here. Okay. So event A, event B, do they have some in common? Yeah, they both got a 2 and a 4 in common. So they both got the 2, they both got the 4. A also has a 1 and a 3. B just has a 6. Okay. And forgot to do this earlier, but there's a wider universe. And there's one number that isn't showing up on this list at all, and that's a 5. And it's also possible you could roll a 5, right? Okay. So you could roll, here's like the wide universe. You roll any of these 6 numbers, 1 through 6. Okay. Here's event A, here's event B, there's some overlap. Okay. So actually start with the question they did not ask. If they said, what's A intersection B? What's the probability of like both events happening? Or how many outcomes, I should say. Okay, you could roll a 2 or a 4 if you go, right? But if they say A union B, which is actually what they're trying to get at here, A union B, okay, that's all 5 of these numbers here. So that'd be 1, 2, 3, 4, and 6. Yeah, here. All right. Complementary, actually they introduced complementary down here. So the complement of A consists of all the outcomes in the sample space that are not included in the outcomes of A. Ooh, right? Right. So if I said, looks like they're designating this with what do you call it? Okay, like a little tick mark up here. It's like an apostrophe type. Right? Okay. So they're saying that the probability, so we're going back to probability of A prime, okay, is equal to 1 minus the probability of event A happening. Okay. So to go back to this dice rolling, okay, if I said, what's the probability of A intersection B, that could be, okay, so 2 out of 6 possible ways to roll a dice, or so it'd be like 1 and 3 would reduce to. Okay. What's the probability of this not happening? Well, that would be rolling any of the other 4 numbers, right, out of 6 possibilities. So 4 out of 6 of this not happening. Or what's the probability of this union happening? Well,
we got 5 possible ways out of 6 dice rolls, so 5 out of 6 is happening. So the complementary to that would be 1 minus that, which would be 1 out of 6, which is just to say you'd be rolling a 5. Okay? That's more what we're getting at here. Okay? And a lot of times it's depending on how the question is framed, it's easiest to solve it this way. You say, like, what's the probability of something not happening? You say, what's the probability it does happen? And then say 1 minus that to say it doesn't happen. All right, so let's look at example here. Complementary event. Pandu subscribes to a movie streaming service for movie night. He's going to let the program randomly pick a movie from his list of favorites. Ooh, that sounds fun. What's the probability that a comedy movie will not be chosen? So we've got all these different genres and all these movies within the genres, right? Now, if you picked a movie completely from random, it looks like there's a bunch of this genre, a bunch of this genre, but there's hardly any of these, and there's hardly any of these. Okay? And so there's different likelihoods for different genres. So example 4. Okay. So if I said probability of comedy being chosen, I'd say, well, how many comedies are there divided by how many total movies could you choose from? Okay. So it looks like there's 112 comedies. And for the total number of movies, you'd want to add all these up. Here, you can do this real fast. Well, it's 44 plus 109 plus 8 plus 112 plus 13, 35, and 29. It comes out to 350 movies total in the system. Okay, 112 are comedies. Okay, so the probability that it does pick a comedy is this ratio, which turns into this as a decimal or this as a percentage. Right, so this ratio, this decimal, this percentage are all the same. But that's not what they asked. They asked what's the probability of it not being a comedy, right? Which is called complementary event. That's what this says here. Complementary event. Right, so 1 minus, okay? So probability of not a comedy. Okay. We're going to say is 1 minus 0.32. I'm playing off the decimal version right there. What would that be? That would be a 0.68, I think, right? Or 68%. Okay. So there's a 68, so okay, choose a movie from random from this list. There's a 68% chance that it would not be a comedy because 68% of the provided movies are not comedies. All right, let's do some book examples. Examples. All right, so I've got some highlighted here. Number 1, a fair die is rolled once. Let A be the event of rolling an even number, and B be the event of a number greater than 4. Find A intersection B. All right, so we got event A is even, which can be a 2, a 4, or a 6 on a fair die. Event B is greater than 4, which could be either a 5 or 6. Okay. Let's do an event diagram here, give you guys a full picture. Okay, we've got event A, we've got event B. Event A could be a 2, a 4, or a 6. But, oh, look, the 6 also applies to B, so I'll put that in the intersection right there. Okay, if you roll a 5, that only pertains to event B. Now, there is a wider universe. There are other numbers you could have rolled on the die. How about a 1 or a 3? A 1 or a 3, which are neither event A or event B. There you go. There's all the possibilities mapped out. Okay. So your book actually asked, what is A intersection B? There's only one possibility, and that's the number 6. So that would be the answer. Okay. Right, now for a wider picture, let me give you guys some other things you could ask. You could have said, what's the probability of A intersection B? And then you would say, well, there's one event happening out of 6 ways I could have rolled the die. Okay, so it could be 1 out of 6 chance of this happening. Okay. They also could have said, what's A union B? And then that would have been all 4 of these possibilities, a 2 or a 4 or a 5 or a 6. Okay. And finally, if they said, what's the probability of A union B? They say, well, there's 4 numbers I can roll that could be either of these events out of 6 ways to roll the dice, and that reduces to 2 or 3 or 67%. Okay. Right, so your book actually asked this question. I boxed in the answer to right here. Right, but they could have asked any of these other questions, and those would have been the answers. All right. Number 5. Okay, 5 and 6. So we got standard deck of cards, maybe 52 cards in a deck. You guys have 52 cards. Okay. Number 5 says a card is selected from a standard deck of cards. What is the probability that the card is a diamond and is also a seven, diamond and seven. Okay. So number five, right? So cards. Here, I'll say 52 cards because there are 52 cards, right? Right, so let's say event could be a diamond, and another event could be seven. Right. Now there's one card that's a seven of diamonds. Right. So seven of diamonds. Here, I'll draw that out. Right. Seven of diamonds. Okay. There are three cards that are sevens that are not diamonds. Okay. So you got seven of clubs. We got seven of spades. And we got seven of hearts. Okay. So those are those other three cards. Okay. Now, as for diamonds, well, there are 13 cards in a suit, right? And we've counted for one already, the seven card. So there's must be 12 other cards. Okay. So 12 other cards go here. Okay. And then in the wider universe, there are cards that are neither diamond nor seven. And so how many of those? Okay. Well, we've counted for 12 here, 13, 14, 15, 16. We've accounted for 16 cards. Remember, there are 52 cards in the deck. So subtract the 16 we counted for. There are 36 other cards, right? Like I could spell them out, like the king of spades and there are 36 of these other guys. Right. Right. So that's what the Venn diagram looks like. Right? And what are they asking for? The probability of the card is a diamond and a seven. Well, there's only one possibility right there. So the probability of A intersection B, right? So diamond and also seven, it's 1 out of 52. Right. Look at that. Okay. 1 out of 52. There's only one card out of 52. Okay, number six. A card is selected from a standard deck of cards. What's the probability that the card has a number that is divisible by two and is black? Ooh, divisible by two. It's an even card. But I think that would not include the face cards. I'm going to say that does not include the face cards. So that's why I'm going to interpret that. Okay. So um, here, maybe I'll make a. So we're looking for. See, so it says probability of divisible by two. Okay. And I'll say intersection, a black card. Right, something like that. Okay. Um, so here, give you guys a picture here. Divisible by two, black. Okay. And then there will be a wider universe of cards you could also draw from. Okay. Well, I think they're let's see. Divisible by two could be the 2, 4, 6, 8, or 10. Right now, there's a 2, 4, 6, 8, 10. That's diamonds, 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 diamonds. Okay, those are all red. Okay, and then you have hearts, 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 hearts. Actually, there's 10 cards there. Okay. I'm gonna blow up this intersection a bit. I didn't draw this big enough. Right, so right here, in this intersection, I'll just draw this bigger. There we go. Okay. We're gonna have also and is black. Yeah, a 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Okay. You can have clubs, 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 clubs. Right. Or you could have spades, 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 spades. Right. It looks like there are 10 cards that are both divisible by two and black. Looks like 10 cards. Okay. Now there's some black cards that are not divisible by two. Right. We got ace, 3, 5, 7, 9, and okay, and then of course ace, 3, 5, 7, 9. Okay, so I'm talking about clubs here and spades here, but there's also jack, queen, king, jack, queen, king. Right, these can all be black. Now there are some other cards too. Like what about the the red cards or something. Okay, red cards that haven't been accounted in these 10 already. Okay, so there's lots of them. So I'll just say, I'll spell it out. Okay. Red, that's not 2, 4, 6, 8, 10, right? Which is a lot of cards right here. Okay, so trying to give you guys a full picture here. All right, so back to the picture, the question then, what's the probability that the card is divisible by 2 and black? Okay. Well, again, there are 10 possibilities here. So the probability of A intersection B, I would spell it that way, because you guys saw the word and. Okay, so we need both conditions true, we need divisible by 2 and also black. Okay. Well, there are 10 possible cards I could pick that would qualify out of 52 cards. Okay, so 10 out of 52 could be the answer. That does reduce, or I could turn that into a decimal if you like. So this is approximately 0.192 or 19.2% as a percentage. Right. Okay. And what is this as a reduced fraction? 5 out of 26, I think. Right. Okay. Okay. So there you go. There's different ways you could write that. There. All right, number 7. Ooh, we got a spinner. That looks fun. Let A be the event that the spinner lands on a vowel. Let B that it lands on the letter J. What are the possible outcomes of A, B, and then A union B? Right. I'm gonna throw in one more. I'll say A intersection B, just for completion. Okay. So A equals, and they give us the curly bracket, so I think they want us to list these out. So A lands on a vowel. How many vowels are there? There's the A, the E, O, U. I think it's just those 4. A, E, O, U. Okay. Now they have A listed twice, but well, since it's identical, I think we could just list it once. Okay. Now, if it was a probability question, I would say, well, the A takes up more space than some of the other letters because it's double counted. So, right, so I double its own probability. Right, but just listing the event, I'll just list it once. Event B is lands on the letter J, which is obviously only the letter J. Right? So what is A union B? Well, if it's either a vowel or the letter J, then it could be any of those. It could be A, E, O, U, or J. Okay. Finally, I'm going to throw in one more. What is A intersection B? Well, there is no intersection between vowels and J because J is not a vowel. So I would say this is the empty set, or if you spell this out, empty set. Right? There is no J vowel. Right? So this will never. That's probably why your book didn't ask it. It's like that. Okay, let's do one more. One more. We got raffle. Raul bought 24 raffle tickets out of 1,545 sold. What is the probability that he will not win the grand prize? So let's go to complementary events. You guys remember the probability of A prime is 1 minus the probability of A. Okay. So this is, you can also call this not A, and this is probability of A, like happening, right? So like probability of A, and this is probability of that not happening. Right, so I'm going to say that the probability of not winning the raffle is the same thing as 1 minus the probability of winning. Right? So 1 minus, well, probability of winning. See, he bought 24 tickets out of 1545 sold. Right? Suppose there's one winning ticket. I think we want to assume that. Right? So one of these tickets is going to win. Okay. So what is 24 out of 1545? Is okay, like this number right here, which is about 1.5%. I guess a percentage. That is the decimal. I'll call it 0.01553. Okay, I'm rounding a little bit. Okay. So if I do 1 minus that, yeah, so 0.9845. Okay, 447. Thanks with that. Or you could call that 98.4% chance of not winning. Because there are just so many raffle tickets, even though we bought a couple of dozen raffle tickets. There's so many more ways to lose than win. There's only a 1.5% chance of winning, or 98.5% chance of not winning. But now you guys can win on Alex.